Welcome to section 2, and in this section we're going to build what's referred to as a walking skeleton, and we're going to start off by creating our API projects for this application. And what is a walking skeleton? What are we actually going to be building at this stage? Well, a walking skeleton is a tiny implementation of the system that performs a small end-to-end function. It need not use the final architecture, but it should link together the main architectural components. Then the architecture and the functionality can then evolve in parallel. And in simple terms, this just means that we're going to have some data in a database. We're going to create an API project that's going to be able to fetch the data out of that database. We're going to create an Angular project that's going to be able to query our API and receive the data from our API that comes from our database, and then we're going to display it in the client's browser. We're going to keep it really simple initially, and then we're going to add complexity as we go along. So there's a few learning goals that we're going to take a look at in this section. We're going to implement the basic API functionality and have an introductory understanding of using the .NET command line interface. When we installed the .NET SDK, that came along with it a command line interface that we can use to do various things with .NET. And one of those things, it allows us to create a new .NET application based on one of several templates that are provided by the command line interface. We're also going to take a look at API controllers and endpoints and understand the structure of an API controller. We're also going to take a look at Entity Framework in this section, and we'll discuss that in more detail as we come to it. We're going to take a look at the API project structure, what's involved in a .NET project, how our application starts up, and also take a look at the configuration and environment variables that we use inside our application. And once we have our working application, we're then going to commit our code into source control, which allows us to take effectively a backup of our code, and it also contains a version history of our code as well. So we're going to take a look at that coming up in this section. What we're going to do in this lesson is we're actually going to create our .NET API project, and to do this we're going to make use of the .NET command line interface. Now, if you're using Visual Studio or you're using Rider, then you do have the facility to create a project from within those tools. But what I'd recommend is, just so that we're all starting from exactly the same place, is you actually come into your command prompt, your PowerShell, or your terminal if you're on a Mac or Linux, and I've just inside an empty demo folder. There's nothing inside here. Obviously, if you're on Windows, you would use dir to display the contents of your directory. And what we're going to do is just make a new directory that's going to store our project files. And this is going to be a dating app, and I'm not very excitingly calling it dating app, just for simplicity. And then I'm just going to cd into this folder. And this is where our project is going to live, both our Angular project and our .NET project. Now, what we're going to use is the .NET command line interface, as I mentioned. And the first thing we're going to do is just check to make sure that our installation was successful. And one way we can do this is just run this command, .NET-info. And this will give you all of the details about the SDKs you have installed on your computer. Now, I've got 17 different versions of the .NET SDK living on my machine, and that's absolutely fine. And the latest version, or the one that I'm going to be running from, is the .NET Core 5.0 Preview 8 version. It's the latest one available at the time I'm recording this. Also, we get details of the .NET runtimes we've got installed in order to run our application. The .NET application uses a runtime, and it goes ahead and gets this from inside this location. And what we have is details of the SDKs we have installed, and quite importantly, this host, useful for support, tells us which version we're going to be using here of the runtime, and this is 5.0 Preview 8, as I mentioned. So like I say, you can have multiple of these SDKs installed side by side if you want to. It will default to using the latest one available that you do have installed. Now what we want to do first of all is we want to create our .NET API project. And what we can do with this command line interface is we can always get help at any particular time by just running .NET-H in this particular case, and this gives us all of the different commands that are available for us to use. Now we're going to be creating a new project and a new solution for our application, so we're going to be making use of the .NET new command, and we'll also make use of the solution command, the SLN command here, to add our project to the solution when we create it. So what we'll do first of all is we'll go and get more information about what we can do with the .NET new command, and we can get contextual help by typing in the command we want to use followed by -H. And once this opens, then we get a list of all of the different templates that are available with the .NET 5 SDK. Now there's a huge range of choice inside here, but there's a couple of things that we want to create. First of all, we want to create a solution file, and this is a container for our projects. And we're going to create a project template as well, and the one that we're going to use is the ASP.NET Core Web API. Now, .NET has recently been renamed to .NET 5 for simplicity because the original .NET framework went up to version 4, but .NET Core came along and started using .NET Core version 1, version 2, version 3, and they're abandoning the full .NET framework, which was only usable on Windows, and .NET Core is the future of .NET. And to keep everything consistent, instead of using .NET Core, it's now just .NET 5. But we still have the same templates being named as .NET Core. As these get updated, and possibly when .NET 5 is released, then these will change to just ASP.NET Web API instead of Core API. At the moment, they still make the distinction in the templates. So what we'll do first of all is we'll create a new solution file, and we'll say .NET new SLN. And what this will do is take the name of the containing folder as what it will call the solution file. And if we just list the contents, ls on a Mac or dir on Windows, then we can see that we have a solution file. And this can be used to open up our project in Visual Studio, in VS Code, although VS Code usually just uses a folder to open the solution rather than a solution file. But other IDEs such as Visual Studio or Rider can make use of the solution file. Now we're only going to have one project inside here, and what we'll do is we'll create .NET new, and this time we'll say Web API, and we'll give it an output directory because we want our API project to be contained in its own folder. And what we'll do is we'll just simply call this API and press return. And we can see that this has been created, and if we list the contents again, then we can now see that we have a folder as well as the solution file for our project. Now the last thing we want to do here is we want to add our API project into our solution, and to do that we can use the solution command, and we can say .NET SLN, and then we can say add, and then we can just say API and press return, and our project gets added to our solution. So what we want to do now is open up our project inside Visual Studio Code or your IDE of choice. As I mentioned before, everything I'm going to demonstrate will be using VS Code. So what I'm going to do is just open up VS Code, and this opens up and we see the default welcome screen, and what we want to do is just use this tab on the left, and we want to open up the folder, and I'm just going to click on Dating App, get the folder, and click on Open, and this opens up our application in Visual Studio Code. Now what I'm going to do next is go through a few tips and things that we want to add to Visual Studio Code. So if you are using Visual Studio Code, the next lesson I'm going to go through that. If you're using something else such as Visual Studio or you're using Rider, then I'm going to presume that you know what you're doing with those applications and not cover anything about those. But for those of you using Visual Studio Code, I'm going to go through and show you how you can set it up for C# development. And that's coming up next. So what we're looking at here is the default installation of Visual Studio Code without anything added to it. Now, as I mentioned, if you're not using Visual Studio Code, you will get no benefit from this lesson, so please skip ahead to the next one. This is for those of you that are using Visual Studio Code. And like I say, on its own, it's just a very colorful text editor, but in order to compile and debug C# code inside Visual Studio Code, we need to install some extensions to help it do so. So what we'll do is we'll just head over to this Extensions tab, and what we want to do is search for C# inside the Extensions Marketplace. And the first one we want to install is C# for Visual Studio Code powered by OmniSharp. And this gives us development tools for .NET Core, C# editing support including syntax highlighting, IntelliSense, go to definition, find all references, and debugging support as well. So we need this one before we can do anything with VS Code, and I'm just going to select a theme, which is just the default dark in my case. And once that's gone ahead and installed, then what you'll see is you'll get a pop-up here saying that required assets to build and debug are missing. Do you want to add them now? I'm going to say yes, that we do want these, but if you missed it and you just click no or you click the wrong button, then what you can do is use a Visual Studio Code command to go ahead and do what that just did. And on the background in VS Code, you'll see some keyboard shortcuts. And the first one we'll look at is the show all commands, which in my case on a Mac is Shift, Command, and P. So if I press these, this is going to give us a command window. And what we want to do is just search for assets. And what this will offer is .NET Generate Assets for Build and Debug. So if you did miss that prompt, then you can always go and click this command to go ahead and do exactly the same thing. So let's continue installing extensions. And we need another one, and it's called C# extensions. Now there's two in this list. There's this one, which has been abandoned and is no longer under development. But there is an exactly the same name called C# extensions, which is based on the original one, and we'll go ahead and install this. This extension just makes our life a little bit easier when working with VS Code, so that we can create classes inside here simply by right-clicking a folder and creating a new class, and it will give us a template for that class. It's got a few other tricks that we'll use as we show how to use this in the course, but for now that's what it's going to do for us. And another one that we'll use just to tidy things up inside VS Code is to install an icon theme. The one that I quite like is Material Icon Theme. I'm just going to go ahead and install this one and select the Material Icon Theme. And if we go and take a look at Explorer, we'll see that our folders icons have changed, and we get different icons for each of the different files inside our solution. So it's a bit cleaner and it just looks a little bit better. So a couple of other things I like to do with VS Code. First of all, I want to turn on autosave. Whenever we make a change to our file, it's going to wait a few seconds and then automatically save our changes. This is very helpful, so I'm going to click that and we should see that the autosave is now enabled. And what we could also do, if we just go into Preferences and then Settings, and you'll get to settings from the normal Application Tools window inside a Windows computer if you're using that. A few things I just need to change inside here. If I want to change the font size, then I can come in here and do this. I'll change it to 17 so that you can see what I'm typing a little bit easier. And I'll also do the same for the console and also for the terminal as well. As inside VS Code, we also have an integrated terminal window, which I believe is defaulted to PowerShell on a Windows computer, and on a Mac then we can just get to this by pressing the shortcut key, which is highlighted in the window, to toggle the terminal. And in my case that's just Control and apostrophe, and this brings up our terminal window inside here. And then we can add new terminals if we want and choose from a different list. This is incredibly useful and is one of the really cool features of VS Code. And there's a couple of other things that I like to do inside here. There's a couple of folders in here, a bin folder and this obj folder. Now every time we build our project or do something with our project, then these folders are recreated, but we never actually interact with these folders at all whilst we're developing our application. They might as well not be there, but they are necessary. So one of the things we can do is hide these folders. And if I just go and click on Code and Preferences and Settings, I just want to look for Exclude. And we can configure files or folders to exclude from our solution window here. So I'm just going to click on Add a Pattern and just follow the guidance here where we've got different options above. I'm just going to say */ and then I'm going to say obj as one of them. And I'm going to do the same for the bin as well. So / bin and click OK. And all that does, it just tidies up our solution window. It doesn't delete the folders, they still exist, they still get recreated. It's just that they're not going to be in our face as we develop the application. And there's just one other setting that I want to change in here as well, and that's to do with how the folders are displayed inside here. By default, they will be shown in a compact mode. And I'm just going to change the option for Explorer to compact folders and turn that feature off. And it just means that we see the full folders. You may have noticed before with the obj and the bin folder that they had underlines for the different folders. I prefer to see them dropping down. And this is all we're going to do with VS Code for now. In fact, there's one more thing just before we go to the next lesson. We'll just open up the command palette one more time and just search for path inside here. And just make sure that you've got the shell command, install code command in path enabled. So I'm just going to click on this and we get the notification saying that was successfully installed. And what this means, if I quit out of VS Code, and if I go back to my terminal window, what I can do is just type in code followed by a period. And this then goes ahead and opens up VS Code. It's just a bit more convenient to do it that way. So these are the extensions we needed to get started. What we'll take a look at next is what we get inside our template when we create it. Okay, so this lesson is aimed at you that have, or aimed at those that have installed .NET 6 onto their machine and have created a new project using the .NET 6 version of the template. There are a couple of changes that Microsoft have introduced, and they refer to it as the new hosting template. Now, we're going to deal with this and talk about it at the end of the course because all of the demonstrations were used using the .NET 5 and prior, the classic hosting model. So there are some changes in the program.cs class. This is going to look very different or a bit different to how the demonstrations look. And there's an additional class that's missing from this folder, again to reduce boilerplate, called the startup.cs class. That's missing as well. Now, these are heavily used throughout the course. And so that the demonstrations work, because all of the code in the traditional or classic hosting model is still perfectly valid in .NET 6 and beyond. And many of the examples you'll see on the internet are making use of this classic or traditional hosting model. And this code here is .NET 6 only. Now, like I say, we'll talk about this at the end of the course, but so that you don't run into any problems and you avoid any confusion between the two hosting models, we're going to create all of the code for this project using the classic hosting model and making some changes in these files. And then at the end of the course, we'll refactor back to using the .NET 6 hosting model. I hope that makes sense. And what I've provided to help out with this is there's a zip file attached to this particular lesson with a program.cs class and a startup.cs class. And we're just going to copy these two files into our clipboard. Once you've extracted it, you'll have a folder with these two files in, and we'll go back to our project and we'll right-click the API, we'll reveal in Finder, and then inside the API we're going to paste these two items and replace the existing content in that folder. And if we go back and take a look at what's inside the program class now, we've got the classic hosting model, which includes this main method, and it makes a call to the startup class that we've also added here, and inside is the traditional startup class that we would have with any .NET project. Like I say, don't worry about the changes because we'll discuss them at the end of the course. I think it will be useful to take a look at using the .NET 5 version because all of the sample code that's out there on the internet that you might run into is going to be using this hosting model. So it's good to know about it and we'll cover the .NET 6 stuff at the end. One other change they've made inside these templates, different to how it is in a demonstration, is inside this properties and launch settings.json file. Now, they used to use a very consistent port number for the HTTPS version and the HTTP version of the app when we run it, and we're going to make that change here as well. And we're going to say for the HTTPS, we're going to switch the port to 5001, and we're going to switch the HTTP port to 5000. This matches what we're doing in the demo as well. I think Microsoft have changed it because when you do create a separate .NET application and you're running both at the same time, it's going to cause a problem if you try and run both on the same port. So when you create a new project now, it generates a random port number, but for consistency and what we're doing and the demonstrations in this course, they all use port 5000 and 5001. So please do make that change as well. And there's just one more thing we need to look at inside our project that's created with .NET 6. We have a couple of flags that are enabled inside this project by default, and I just want to mention these, and we're going to turn one of these flags off. And the first one I'm going to talk about is this implicit usings. Now, when we took a look at the program class in .NET 6, we actually didn't have any using statements inside there. And when we copied the file across from the files that I provided for the .NET 5 kind of, or the classic traditional hosting model for the program class and the startup class, then we have all of these using statements inside there. Now, one of the things that Microsoft have added, and this is to remove all of the boilerplate that we see inside of these classes, is they've provided this implicit usings. And all of these using statements that we see here are actually implicitly enabled globally in our project. Now, the reason I don't particularly love this feature on its own is that this implicit using statement has auto-generated a file inside this obj folder, and the compiler creates this. This is not something that we create or we interact with. But inside the obj, inside debug, inside .NET 6.0, there's a file called API global usings.g.cs. And this contains auto-generated global using statements that are accessible from anywhere inside our project. And global using statements are great because inside our classes, we make use of these, and we end up repeating using statements over and over when classes typically need the same using statement. And system is a very common one that's used in almost every class that we create if we need something like a date time object. So that's what this particular flag does, but we're going to leave it enabled because this file on its own doesn't do any harm. We'll find that in our startup class we have a lot of unnecessary using statements that can be removed. I'm going to ask you just to ignore them for now, add them if you wish, but where we see them sort of dimmed out, that means they're now unnecessary. You can use the quick fix to remove all of the unnecessary usings. For now, I'd suggest just ignoring them and adding them where you need them, as I demonstrate throughout building the project in this course, and not worrying too much about them. Because if we do remove them, and I'll show you an example of what we need to do if we do remove this, and I'll just comment out this line. There's a couple of classes inside our projects, the demo projects, the Weather Forecast Controller, for example. If we take a look at this, because this was created with .NET 6, it doesn't include any using statements because they're provided as part of the implicit usings, and we would then need to go through and actually add all of the using statements necessary for these demo classes to work. So on that basis, it's just easier to keep it enabled rather than going through and adding anything that's missing, and we should find that the error then goes away, and it should go away eventually. And sure enough, it's back to how it was, and our Weather Forecast Controller is no longer showing an error either because the implicit usings are available. The other flag I want to mention, and we are going to turn this one off because it will cause some problems, is inside the API folder. Let me just demonstrate what this is for. So it's called nullable, and in our project we're going to have things called nullable reference types. And an example of a nullable reference type is a string. Any string property that we create can be set to null, and that's perfectly acceptable in the C# world. We won't get any warnings about it, but when we attempt to use it, if it is null, and then, for example, we wanted to do something with this string, then we're going to get an exception. And the idea of this flag is to prevent those kind of exceptions. Now, this flag was not available when I originally wrote the code, and the idea is that the developer is going to be very specific about what they want to allow to be null. And in this case, when we have that flag enabled, we have to add a question mark to any property that we want to be allowed to be null. And if we do not provide that question mark, I take the optional parameter away, then we're going to see these warnings in our code saying that this must contain a non-null value. So because this wasn't available, and I haven't demonstrated using explicit optional parameters for each of these different items, then we are going to remove that flag from our project. We'll discuss it again at the end of the course, but so that we can make progress and not need to worry about what's inside here, we're going to remove this flag from our project and remove it completely. What this will do is, if I go back to that same class, is highlight a problem inside here to say that this annotation for nullable reference types should only be used in code with a nullable annotations context. And we've actually taken that away, so we don't need that question mark in that file. And this is now operating as it does in .NET 5, and that's how the code for this training course has been built and provided. So that's how we're starting, or where we're starting from. There are a couple of other minimal changes. For example, the namespace is on a single line instead of being inside a bracket for the controller here. And in a .NET 5 project, then this would be inside that namespace. And Microsoft have just adjusted that in a small effort to reduce a bit more boilerplate and reduce the lines of code as well. But with those changes in place, we're now good to go and continue the rest of this course using .NET 6, but using the .NET 5 hosting model. So what we're going to do in this particular lesson, we're going to run our application, make sure it's working, and then take a look at the project files to see what we get inside here and see what we'll be using throughout this course as well. So what we could do first of all is we'll open up the terminal using the keyboard shortcut, which is in my case Command apostrophe. It may be different to yours, so please double check. And what we want to do is change directory into the API folder, as this contains our startup project, or our only project, so we want to CD inside that. And then what we can do is use the .NET command line interface to run our application. So we'll just type in .NET run, press return, and then this is going to build and run our application. And it may take a few seconds the first time you do this, but what this tells us is that our application is now listening on HTTPS localhost 5001 and on localhost 5000. So we've got an HTTP address and we've got an HTTPS address as well. Now for this HTTPS address, we need to make sure that our browser trusts the certificate that's provided with the .NET SDK. And what we can do to achieve that, if I just stop my application and clear the console, is we can use a .NET command and we can say .NET dev -certs and then HTTPS --trust and press return. And it needs elevated permissions as well. So if this command doesn't work and you're on Windows, then you'll need to run this as an administrator so that your certificate can be trusted. If you're on a Mac, then it's going to ask you for a password to elevate your permissions here. And it tells me that a valid HTTPS certificate is already present. I've already done this on my machine, but you may well need to do this on yours in order for your browser to trust the certificate from .NET. So please go ahead and run this command so that your certificate is trusted. And we can press Ctrl and C to shut down our application, and it also tells us we're running in development mode. So what we'll do is we'll just go across to the browser and we'll take a look at our application. So if we browse to this and we type in HTTPS localhost 5001, we'll use the HTTPS address for most things in this case, what we'll find is we get the local host page cannot be found. Well, it tells us that it's listening on this address, but what this is an API project. And inside an API project, we have controllers, API controllers, and these provide the routing endpoints for where we can find our application. Now, if we take a look inside the weather forecast controller, this is the freebie controller we get when we create a new web API. It tells us that we've got a route for this called controller in square brackets. And where we see this controller in square brackets here, this is a placeholder, and it gets replaced with the first part of the controller name. So in this case, controller gets replaced with weather forecast. So what we can do with that bit of information is we can head back to our browser and we can say / and we want to go to weather forecast. And if we press return, then you're going to see something like this. Now, this is a list of weather forecasts just to show that our application is working. And if we go back and take a look in a bit more detail about this controller, we can see that we have different summaries, a string array of different summaries. It could be freezing, bracing, chilly, cool, etc. We also have a property for an iLogger. Okay, we'll come back to that. And then we have some other information in here as well. None of this is important for what we're doing right now. What we really want to see is the controller endpoint, and this is the HTTP GET. So when we made that request from our browser, we were making an HTTP GET request to our API, and then what this does is returns the results of this code to an array. Now, the code in here is not important at the moment. What we'll be doing is creating our own controllers with our own endpoints and learning about the logic inside there as we go along. But what this is effectively doing is just returning an array, a list of, let's call them weather forecasts. And that's fine. We know that our controller endpoint with the HTTP GET to the controller route, the weather forecast, is being displayed in our browser. Great. And we will be looking at controllers in more detail because we're making an API. And these are going to form the basis of our entire application. So don't worry about my lack of detail at this stage. What we also want to do is understand how our application starts. How does it work in the first place? Well, every .NET application has a program.cs class, and within this particular class is a main method. So when the .NET run command executes, it's looking for this method, and then it's going to run any of the code inside here. Now, the code inside here calls another method inside this class called createHostBuilder. And if we take our mouse and we hover over the actual method itself, the host.createDefaultBuilder, then this tells us what this method is actually doing. And this initializes a new instance of the HostBuilder class with some pre-configured defaults. It's going to set the content route path, where to get the files that are part of our project. It's going to load our configuration. Now, there's several places that our application can get configuration information from. One of them is our environment variables. We can also add variables to the command line arguments when we run our application. And there's a couple of files that we have inside our application called appsettings.json and appsettings environment name, in our case development.json as well. And it also takes the configuration from there as well. And then it also sets up logging and it returns the initialized host builder from this. And inside this method as well, it also tells us what else to use when starting our application. And it points to this use startup class. Now this startup class is contained here, and what we have inside here is our configuration is being injected into our startup class, so our configuration. And when we're talking about configuration, let's just take a look at one of our configuration files, the appsettings.development.json. Now at the moment, the logging level for development, in my opinion, is set too high. It's set to warning. And this doesn't give us the most amount of information which we want when we're developing the application. So what we'll do is we'll swap the log level for Microsoft to information. And if we go take a look and I stop the application, I'll just clear the console and I'll restart the app by using .NET Run, then we'll get more information when something is happening. And if I go and browse and refresh my endpoint once again and go take a look at my console, we can now see that we get a lot more information inside here about what's going on when we hit that particular endpoint. We can see that we made a get action for the weather forecast controller, for instance. So we'll leave that logging level as it is because that's going to supply us with useful information if something goes wrong. So let's head back to our startup class once again then. And we've got two methods inside here. We've got a configure services method and we've got a configure method. And inside our services, this is our often referred to as our dependency injection container. If we want to make a class or a service available to other areas of our application, we can add them inside this container, and .NET Core is going to take care of the creation of these classes and the destruction of these classes when they're no longer used. We'll come on to this in more detail as we use it. The next part is the configure method, and this is used to configure the HTTP request pipeline. As we made our GET request from our browser to our controller endpoint, then our request goes through a series of middleware on the way in and also on the way out. So first of all, we check to see if we're in development mode, and if we are and our application encounters a problem, then we use the developer exception page. We also use HTTPS redirection, so if we did come in on a HTTP address, then we get redirected to the HTTPS endpoint. We also set up routing, and we've seen routing in action because we were able to go from our browser, the weather forecast endpoint, and get to our weather forecast controller. We've got app use authorization, which isn't doing much for us at the moment because we haven't configured any authorization. And then we've got the middleware to actually use the endpoints, and we've got a method here to map the controllers. And this takes a look inside our controllers to see what endpoints are available. And if we once again go back to the weather forecast controller, we can see that we have a route, and where we've got the HTTP GET, this is our endpoint. So any GET request that goes to our API with the weather forecast route will get sent to this particular endpoint, and we return the data to an array. So another file I just want to quickly mention, inside our properties folder we have a launch settings.json. When we run our application using .NET Run, then it takes a look inside this section to see what it should use when we start our app. Now, because we're creating an API, we don't really need to launch our browser, so I'm going to set that to false. The launch URL, if we're not launching a browser, is irrelevant, so we'll ignore that. And then we can see the application URLs where we start our application. We can see that we're running off localhost 5001 on HTTPS and also HTTP 5000. And then we've got a section for the environment variables, so that when we start our application, it knows that we want to run it in development mode. And the other thing I want to mention at this point as well is the ability to add a file watcher to watch for any changes we make to our files. So at the moment, we're just using .NET Run, but what we can do is use .NET Watch Run, and this will add a file watcher and keep an eye out for any file changes that take place in our application. So for example, if I just go back to the weather forecast controller and take a look at the different options we have, if you're living in the UK, then there's a couple of temperatures here that are completely irrelevant, such as sweltering and scorching. So I'm just going to remove those just to as an example of a file change, and you can see that the application then rebuilds itself and then restarts the application. And if you go back to the browser and just refresh the page, then you'll find that there's no longer a sweltering or scorching option inside here. So our application rebuilds and restarts, and we'll just use .NET Watch Run as we build our application. The combination of autosave, the file watcher, means that when we do make a change, we just have to wait a few seconds and then go and test that the change has taken effect. And this concludes the very brief run through of the files we have inside our project folder. We'll be coming back to these all the time, so please don't worry about the briefness of this lesson because we will be making use of what we've taken a look at as we build our application. Okay, what we're going to do now is create our first entity. And because we're creating a social app, a dating app, then it's fairly obvious that we're going to have users in our application, and users are going to form the big part of our application. So this makes sense to start with this as the first thing that we create. And what we'll do to maintain some level of organization in our application, we'll create a new folder and we'll call this folder Entities. Now, an entity is really just an abstraction of a physical thing. A physical thing in our application is a user. So we're going to create a user entity that's going to contain user-related properties. We're going to keep things nice and simple to start with. So what we'll do is we'll right-click and create a new class. And we have this facility available to us because of the C# extensions we installed earlier. Obviously, if you're using another IDE such as Visual Studio or Rider, please just create the classes as you normally would inside there. But if you're using VS Code, then you'll have this available. And what we're going to do is call this particular class app user and press return. And the C# extension goes ahead and creates the templates for a basic class inside C#. Now, I've called it app user because user is a very, very overused word in coding. So app user gives us a way to easily identify that this is our user and not a user coming from a different part of the .NET framework. And what we'll do to keep things nice and simple is we'll give it two properties. And what we could do, by the way, if you're new to this sort of thing, to create a property, and this is called an auto-generated property or an automatically implemented property, then we just use the prop keyword and then press tab. And then we'll tell our property what type it's going to be. And this is going to be our ID field. So we're going to give it an integer and we're just going to set the name of the property to ID. Now, if you wanted to be creative at this point and call it something than ID, I would advise against it, because what we're going to look at with Entity Framework coming up is how it uses conventions to do certain things. And if you preferred to call something, for example, you wanted the full name identity instead of ID, then Entity Framework, when we do take a look at this, will not recognize this as an ID field. By giving it the name ID, then when we do look at Entity Framework, it's going to recognize that this is going to be our primary key of our database, and because it's an integer, it's also going to set up our database so it automatically increments the ID field every time a new record is added to the database. So because of conventions, I would recommend sticking to exactly as I'm naming things here. You can call it ID, of course. The convention is either ID with a lowercase d or ID with an uppercase D, but I prefer to call it with a lowercase d. The other property that we'll have inside here is a property that's going to be a string, and this is going to be for our username. Now, again, I'm going to mention to go along with what I'm doing here very, very specifically, and you might prefer to use username with lowercase. I do, that's my personal preference. But I know that later on in this course, we're going to want to introduce something called ASP.NET Core Identity. And that uses a username with an uppercase N. And what this basically means, if we did use a lowercase n, we would need to do quite a bit of refactoring later on in the course. If we stick with an uppercase N, then we need to do less refactoring. And this is just the two properties that we're going to use at this time. Just a couple of other things to point out about these properties. I mentioned these are automatically implemented properties, but what we can have is the full implementation of a property. And if we use prop full, for instance, then what this allows us to do is specifically get and set the properties inside here, but we're okay with using auto implemented properties, the shorthand version of this, so that they can be getted or setted from other classes in our application. So we'll typically use the shorthand version when we're creating properties. Also, they have an access setting. This is a public property. Public means that this property can be get or set from any other class in our application, and same goes for the class itself. Other options we have in here are protected, which means that this property can be accessed from either this class or any classes that inherit from this class. And then we also have the private access modifier, which means that this property is only accessible from inside this class itself. Now, because we need Entity Framework to both get and set these properties and the entity itself, then all of these need to be public. And because we now have an entity, what we're going to use to create our database, to query our database, and do just about everything with our database is we're going to introduce Entity Framework, and we'll discuss that next. What we're going to take a look at now is a brief introduction to Entity Framework, something that we're going to be using significantly in the development of our application. And we're going to take a look at this introduction just to give you a sense of where it fits in our application and what we use it for. So the first question is, well, what is it? Well, it's an object relational mapper, and its job is to translate our code into SQL commands that update our tables in the database. Now, prior to .NET 3.5, which was released a long time ago in 2002, not .NET Core 3.5, we're talking about the original .NET framework, we often used to write something called ADO.NET code to save or retrieve application data from an underlying database. We'd have to open a connection to the database, create a data set to fetch or submit the data, then convert the data from the data set to .NET objects. And it was a cumbersome and error-prone process because we would be writing the database access code as SQL code, which would be in the form of strings, and it's very easy to make mistakes. So Microsoft has provided a framework called Entity Framework to automate all these database-related activities for our application. So what we have at the moment is an app user entity, just a simple class that we've created with an ID property that's an integer and a string property for the username. What we're going to introduce is Entity Framework. And when we add Entity Framework, we need to create an important class that derives from the DB context class that we get with Entity Framework. Now, this class acts as a bridge between our domain or entity classes and the database. And this DB context class is the primary class we use for interacting with our database. Now, what Entity Framework does for us, if we just take a look at an example, is it allows us to write something called link queries, which is what we see here on the left. We say that we get our dbcontext.users because when we add our user entity to our dbcontext class, then we'll have access to a property called users, which represents our users table in our database. And then, for example, we could add a new user with an ID of 4 and a name equal to John. Now, Entity Framework works with database providers. Now, the one that we're going to use purely for development is SQLite. SQLite means we don't need to install a database server, and SQLite just uses a file to store our database. Now, SQLite is not production worthy, but it is a great database for development because it's very portable. We don't need to install anything, and it simply adds a file into our project folder for the database. Later on, we will take a look at changing this to a production worthy database. But for the development, we're just going to stick with SQLite. Now, I know some of you Windows guys are going to be saying, can't we just use SQL Server? Yes, of course you can. But for development, I'm going to stick with SQLite because SQL Server is not cross-platform, whereas SQLite is. It will work on any operating system. So our SQLite provider, or our database provider, is responsible for translating our link query on the left into a SQL command on the right. And it will translate our code on the left into an insert into users with the ID and name, and then it will insert the values inside there, and we'll add that particular user to our database. So just a couple of features to go through. Entity Framework allows us to query our database using link queries that I mentioned very briefly before. It also gives us change tracking. It will keep track of, Entity Framework will keep track of changes occurring in our entities which need to be submitted to the database. It also allows us to save the database, and Entity Framework will execute insert, update, and delete commands to the database, as the DB context class gives us a save changes method that we can use. We'll see that very soon. It also gives us concurrency. It uses optimistic concurrency by default to protect overwriting changes made by another user since data was fetched from the database. It also deals with transactions, and it provides automatic transaction management whilst querying or saving data. It also includes first level caching out of the box, so repeated querying will return data from the cache instead of hitting the database. It also offers built-in conventions, and when I was talking about why the ID property needs to be named ID, is because Entity Framework follows conventions and includes a set of default rules which automatically configure the Entity Framework schema, or the model that we use to create our database. We can also configure our entities, and there's ways to configure these so that we can override the conventions if we wish to do so. And it also offers us migrations. And we'll take a look at this soon, but this gives us an ability to create a database schema so that when we start our application or we run a particular command, we can automatically generate our database in our database server. Now these are pretty powerful and they're very convenient because they take a look at our code that we write and then creates the appropriate database that we need, or the database schema that we need to manage our database. So we don't need to create our database manually. Entity Framework can do this for us. There is another way around. This is referred to as code first database creation. You can do it the other way around. You can create a database first if you want, and then go ahead and create your entities to match up with the database, but it's far more convenient to use migrations to do so. And all of these features we'll be taking a look at coming up.